Good afternoon, everybody. Today we're going to talk about problem number 2 of 2022 IOI prison. The problem is like this. So you have 500 prisoners, and then there are 2 bags with money, A and B. Then there is there's number of coins in each bag. And the number of coins in A is different from the coin in B. So then there's a whiteboard. Then each prisoner can go to a room one by one, and then they can look at the bag, and they can look at the whiteboard, and they can write something on the whiteboard. So the question is, how can they, if they can determine which bag has more coins than the other, they can tell the police. If they told it correctly, then they're released. If they told it wrong or they cannot figure it out by the end of all 500 prisoners, then they go back to prison. So here is basically here is some examples. Right? So the way you can grade it is you can write a number, right? You can write the number on the board. I mean, let's say the biggest number you can write is some X. Okay, so if this number is less equal 20, you get basically the maximum point. That's what we want to shoot to, right? So that's basically the question. So we have done problem like this before, if you remember. This is basically ask you to write a stage mission, right? So at each time when person coming in, you write on the board something that indicates the stage of that thing. So let's, for example, we want to compare A and B, right? So let's say there's 2 numbers. So for example, A and B, we can turn them into a binary description, right? For example, A would be 1011011 or something. B could be 110 something. Okay, so every time you can have a prisoner coming in, you can say if you have the first prisoner coming in, you say, let's say here's your whiteboard, right? First prisoner coming in, and this prisoner, if they look at, so this prisoner look at A, okay? If for example, if A is 1, they write something, right? So if A is 0, they write something else. The next prisoner coming in, right? So they look at B. So if they know the stage, then if this number writing here indicates what is here, then he can immediately compare, right? If they say, for example, if this is 0, and then here he indicates, oh, I already know it's 1, then I already know, okay? Then otherwise I can, then he can say, hey, I already know which one is bigger. Otherwise, he will say, oh, I don't know, I'll move on to the next one, right? So first you need to know, each person comes in, he need to know whether I'm reading A or whether I'm reading B, okay? So we can use, each prisoner knows which number, right? So let's say we know I, right? So I'm prisoner 1, 2, 3, going forward. So I first need a flag, right, to indicate I'm at the, I'm going to be A or B. So the first prisoner, he will write, let's say he will write a 3i. Okay. So then, so that's indicate I'm a branch, right? So then this one comes in, he look at the board, oh, it's something divisible by 3, then he knows, oh, I'm the one I need to look at A. Okay. So if A is A at the the ice location, right? So the highest location. Okay. So then ice location from the front. Okay. For ice location from the front, not ice location from the back, right? So if that location is 1, then let's say we write it as 3i plus 1. Okay. If it's 0, they write at 3i plus 2. Okay. Then B comes in. B comes in if, for example, B, if this is 1, B is 0, then he can say, oh, B is smaller. If you see this is mod 3, this number writing on the board is mod 3 by 2, then he knows 0. If this is 1, says I'm bigger, right? Unless they're all the same, then you will write, if it's all the same, if they're equal, right, then I'm going to write 3i plus 3. Okay. So then the fourth one comes in, you say, oh, I'm 3i, I look at it, oh, it's basically 3i plus 1, right? So you say, oh, the number I look at is 3i plus 1. Now I'm going to write, or he can do something else. I mean, then I can write my 3i again, right? I mean, you can use any other numbers, I could write 7i if I want to, right? But I want this number to be as small as possible, so I write 3i plus 1, okay? So if I do this, is basically every 3 chunk, every 3 person, I compare 1 digit, right? So how many digits I have? It's 5,000, right? So let's do a calculation. So I have the maximum I, right? Sorry, n. The maximum n is 5,000, right? If I remember, yeah, 5,000. So how many digits I have? I have 1,000 raised 2. So I have 12, more than 12 digits, and each digit I need 3%. Okay. So my n is 36. So I got this, and obviously that's not good enough. So I got, 37. Okay, so that's not good enough. So however, if you look at it, if you look at this further, right? When the person comes in, the first person comes in, right? If the first person comes in, remember, first person comes in is 0, right? Then first person, he does not need to look at this, right? The first person, if you remember the question, it says the first person comes in, what's written on the board is 0. Okay. Then I do this. Then I know it's even or odd, right? So I can see it's based on whether it's even or odd, what's written on this thing. I know it's the digit, the ice digit is is 0 or 1, right? Then I can here, I can just look at B. Then I can look at. Otherwise, then I just, if they're different, then I can make a division. If it's the same, then I can just look at the next one, right? So actually from one to another, you can, instead of 3, you can use 2 to do this. So instead of 3, right, log 2 of n, you can actually use 2 log 2 of n, right? So that is, so you can do 2 times that. You can do 25. Okay, so you can do 25. 25 will get you here, slightly better. Okay. So this is, I use power of 2, right? So I don't necessarily have to use binary. I can use 3, right? So I can represent each number by, I use binary, right? I can use 0, 1, 2, and use 3. So I can do log 3 of n, and then I have to use a 3% to look at it. So this is 25, right? So this is what we calculate, what, 37? Okay. So I can do that. So if I do 3 times log 5,000 of base 3, I can get to 24. 24. Okay. So 24 is getting closer and still further away from 20. So then we can actually, we don't have to do fixed add binary or use power 3. Maybe certain stage we can use power 2, certain stage I can use power 3, right? So let's think about it. So let's take a dp is the dp of I, okay? Let's say is the minimum x you want, right, in order to do this. So if I take this, break into, let's say, y sections, okay? So then I can calculate dp of I is dp of, I break dp of x, I break x into y sections, right? I have to take the upper range, right? Then I plus y, right? So because I have one number to represent the y sections, and then each of those section, the length of that section is this, right? Uppercase. If you do this, you can figure out, if you do this dp, okay, and then you can figure out is this m is 21. Okay, so still not 20, but there's one more trick. Is, remember he said a and b are different. Remember, a and b are different. So if a is 1, then B cannot be 1. B has to be something bigger than 1, right? So then if A is 1, I know A immediately is smaller. If A is n, then everything else has to be less than n. So I immediately know A is the biggest. Right? Then I should choose A, right? So same for B. So because 1 and n, they're unique. So if that's the case, we can directly return, right? So because he said NA not equal NB, right? So then we can take that from M to 20 because you reduce one of the reduce both sides, right? So you can basically have, in other words, dp of x is dp of x minus 2 because you don't have to do this 2 anymore, right? Of y, you take the ceiling plus y, right? Again, you don't have to do those two. Then each of those can be represented by this, and then you just need one additional digit, y additional digit to represent each subsection, right? So that's that. So then you can use this to figure out that. Then if you do this, you actually find out. So then that's how you're going to, based on different range, you figure out different, different range. You use different, binary or power 3. Then you get m equal 20. Okay, so this is the basically a stage machine. You just need to figure out a way to have a way to write a stage machine. We start with a not so smart stage machine, then we slowly optimize it, right? So we first use a flag, then we find out we can use even odd to represent the stage. We don't have to have a flag to represent the stage. Then we say, hey, we can do, instead of binary, we can do power 3, base 3. Then we figure out that if we can do base 3, then we can, based on the range, we can use different base, right? So then that's a way to DP to figure it out. Then we find that we don't need front and back. So that's the solution for this problem. I will give you in the video, I will give you one example solutions. It actually turns out that's the way they broke it up. Doing all those, that's the way they broke it up. So you can code it after the meeting, or you can look at the answers. So then next week, we're going to talk about problem number 3 of day 1, which is tower. It's another interesting question, radio tower problem. It's actually something we actually kind of did it before. Obviously, if you think about those problems, you say, hey, that's a DP problem. Maybe, right? So think about with the problem, and we were going to talk about it next week. So thank you, and see you next week.